Hey everybody. So I'm going to do a quick introduction about Bytewax, what Bytewax is, and myself. And I often like to start these with a little story, or today at least. I'm going to start this with a little story because I think it's kind of fun. So, we all do things outside of using our computers, or most of us do. And in my previous life, I was a skier, a competitive skier, and this morning I woke up to check on some how my friends are doing that still ski race and they're in competitions, and this video came up on my feed, so I want to share it because it's kind of funny. And I was like having a little bit of a rough morning, and I thought, wow, my morning's not going as bad as my friend Stan, who did this.
Poor guy.
Yeah, he's okay. He will survive. He'll live to ski another day. But anyway, that's just a little intro, and we'll move along. So Bytewax, it's stream processing in Python. Our mission is to make it easier and faster to deploy stream processing workloads and to work with streaming data. So what we did to help get us towards that mission is develop a Python native open source stream processor. And that has a bunch of key supported operations that you can use for streaming that they'll probably be using some of them today, like enriching or branching, aggregations and transformations, and joining. It's cloud native by default, so it runs very easily and scales very easily on top of Kubernetes. It's very extensible. It's part of the strength of the library, so you can develop connectors to different sources and syncs. And then it meets performance requirements in most instances, and has everything you need out of the box. We have a small but growing community of 1,000 people stargazing. Please star us if you get a chance. And 300-ish, I think it's 350 or so Slack members who are actively building stuff with Bytewax, and it's fun to see what everyone's building. Bytewax was started in was open sourced in 2022. And we had our first production use that year. And since then, we've kind of been building more features like adding joins in the most recent release in v0.718. So you can have multiple disparate input sources. We also recently launched the Bytewax platform, which is our commercial offering, but I won't bore everyone with the details of that because you came to learn about how we can build things with Bytewax. So you can think of Bytewax, if you're not familiar with stream processors, is a transformation layer between an input and an output. And so it's just a nice semantics to describe how you can transform data in real time from streaming input sources or non-streaming input sources. But primarily, we've developed semantics to do it with streaming input sources. So at this point, you're like, I came here to learn about LLM applications, not streaming data. So why would I use a stream processor as an application framework for LLM applications, which is a valid question. But I'm here to posit that there are some interesting reasons why you might do that and why we're doing that today. This is outside of the common use case we see people using Bytewax for in LLM applications, which is generally for updating or ingesting data into a searchable and retrievable data source for RAG architectures, which is also going to be used here today. So LLM applications have a unique requirement in that they normally have to maintain an idea of what has happened in the past over a sequential set of prompts and responses. So they need to know what has happened so that for each next response, they can correctly answer what has happened. And that's kind of what you see when you're interacting with things like ChatGPT. And so if you look at what happens where you have prompt 1, response 1, prompt 2, response 2, and they're in order, and you need to know what's happened over that time, it kind of looks like a stream of data. And so in addition to these sort of conversations looking like the shape of streaming data, we have some hard parts about LLM applications outside of them going off the rails, which are funny and also hard to deal with. So storing and retrieving the history of the conversation, routing the right prompts to the right conversation session. If you've ever built an asynchronous application, and you needed to have the right data land on the right worker so that you could actually do the right thing, it becomes very, very difficult. Keeping things in order, obviously we want the conversation to keep in order so we can answer the right prompt, and then connecting to real-time data sources and sinks. So all of these happen to be things that are solved or somewhat solved with a stream processor. And so the benefits of using something like Bytewax, which is a lightweight stream processor, just runs just like a Python script or a Python application, is you can keep the context of the conversation in a stateful step, which you're going to see in this workshop, without additional infrastructure. So, there's no need for you to set up, different, I don't know, Redis databases or Postgres databases where you're trying to, hop over the network and retrieve past information about conversations, which might be quite large, and then, try to use those. You can actually keep those in memory and in state. And because you get key routing by default, you can do that in a way that works for multiple conversations, for multiple users. It's also very easy to scale stream processors across threads, processes, and nodes because they are distributed systems, and that is kind of abstracted away from the end user. They're optimized for throughput, which may or may not be something you're working or you're looking for because you might be bottlenecked somewhere else anyway. But at the end of the day, you're limiting network hops as well, so that's kind of a throughput thing too. Some of the drawbacks of stream processors are streaming is scary, but hopefully after this workshop, it's not. They're generally synchronous, and that's for many good reasons, but it doesn't always fit in applications, but there are workarounds for that, like key-based routing and the such. And for this, it makes sense because we're keeping state and we're keeping order of the conversation. Failure is generally more difficult to handle because you're maintaining state, but for every good stream processor, there's a way to recover. And so Bytewax, which is a great stream processor, obviously has a way to recover. And I'm not sure if that will be shown in this one because it kind of gets in the weeds sometimes, so we'll see. And with that, I will turn it over to the great team at Softlandia, who's going to present the rest of the workshop. So thank you, Mikko and Henrik, for putting together this awesome workshop, and I'm going to be right here alongside you. All right, I will stop sharing, turn it over.
All right, I will take over. Thank you, Sander. Just a second. All right, can you see my screen here?
Yeah.
Yes, Henrik.
Yes, all right. Yes, so this is the team from Softlandia who is organizing this workshop. It's me, Henrik or Henkka, and Mikko. We are two of the co-founders of Softlandia. I personally have almost 10 years of experience in all kinds of software. I've been doing Python, I've been doing C, C++, Lisp, all kinds of things. Nowadays also working with Rust. I've been doing things with robots, things with the web, with the cloud, all kinds of things. Yes, so I think Mikko, you can continue from here.
Yeah, it's Mikko here. Nice to meet everybody. I'm a data scientist here at Softlandia, one of the co-founders, as Henkka said. And I've been working with Bytewax for, I think, two years soon. And at Softlandia, we are a end-to-end focused solution house. That's how we describe ourselves. So anything that has to do with data or AI, we can deliver it end to end. We have expertise in cloud and AI, machine learning, everything it takes. We can build it. And yeah, we've been building on Bytewax for a good while now and enjoying it a lot. If you look at our blog, there's a cool blog post about Bytewax if you need a quick introduction or comparison of state-of-the-art streaming tools. Go check that out. You can see here the QR codes which take you to our LinkedIn profile. So happy to connect with anybody. Yeah, I will be here following the workshop, adding some bits and pieces every now and then. Henkka will be mostly walking you through the code, showing you how to build a full stream processing pipeline with Retrieval Augmented Generation. So what this means is that we will build a bot that has access to your own data, and you can then post messages, post questions to the bot and get answers that are grounded on the data that you have chosen, as well as keeping the conversation history in mind when answering your questions. So yeah, that's what we will be building. We'll go through it step by step, and feel free to ask questions at any time. I'm following the conversation here on Zoom and also in Slack. So if you look at the Zoom chat, you will find a link to a Slack workspace, and this is where we have connected the bot that we will be building today. So make sure to join there if you want to run your own bot in the Slack message stream. Cool. I'll hand it over to Henrik now.
Thank you, Mikko. Yes. So basically now let me switch to the other chat. So now in this Slack instance that we have here, I've shared a link to this GitHub page. In here, you can find the template for the application to start building on top. We also have the API key that you will need to actually connect to the Slack bot that we have running. We are actually using a proxy here. We are not connecting to the Slack directly, and the reason for that is that we will be having potentially a couple of hundred of instances of this pipeline running at the same time, and we cannot just connect that many bots to the single chat instance directly. So we have a proxy server which is actually distributing those messages into the streams here, and we have the connectors for the Slack. So there's the source and the sink. Those are already bundled in the repository. Those are ready to be used and imported in the code. And also in the repository, there is a .env file which contains some of the data that we need to fill in, for example, this API key. So before going into that, I will go back to the presentation. So we will go through this in steps. So the first one is going to be the step one, and this is to build a simple pipeline where we get the messages from the Slack source, and we just output those into the std out sync in the Bytewax. So simple stuff, at least for now. So if you load up the project, it's going to look like this. We're importing the data flow from Bytewax. We are having a couple of things for loading the variables from the .env file, and then we have logging for to actually see something in the console. Then we have a flow variable here, which is actually required by the Bytewax. So you need to have
Henrik, can you make it a little bit bigger for folks?
A little bigger.
For your terminal and your yeah, perfect. And
better?
If possible, a little brighter. I don't know. I don't want you to change your theme, but if you have a theme that's maybe a little lighter, the contrast. I think there's a note. Someone in the chat said it's hard to see the.
Let's see. It's better.
Yeah, cool. Contrast is good. Thank you.
Yeah, this is not as pretty, but maybe better for the recording.
Yeah.
All right. Yes, so we are setting up the logging to see actually something on the screen. Then we are building the data flow. And now for the Bytewax to be able to run this flow, it needs to be in a global variable called flow in this file that we are actually executing with the Bytewax. And here we are actually building the data flow. It's given a name, supercharge Slackbot, and then right now we are doing nothing for it. Maybe I'll show the .env file. So now people that are joining, make sure to have the Yokotai API key here in the .env file. It will not break at the step 1, but it will break at the some step if this is missing. So this is the only thing that you need to fill in this file. All right, so first thing that we will do is that we will actually create an input for this stream. So for that one, we are going to need to use the Slack source. So this is something that's already in the repository. It's in this utils directory, and this is an example of how to extend the Bytewax framework with your custom data. So this is now pulling messages from this Slack stream here. And for that one, we need to actually import the operators also. Okay. We need to import those. Right. So now we have the stream, and then for this first step, let's just add a inspect step so that we can actually see what's going on in the stream, and then we can have that outputted into an std_out. So this is now basically step number 1. So now we can actually run this with the Python-m Bytewax run, and I will give it the file which is called dataflow.
But we cannot see the command here.
Oh, you cannot see the command.
It's a bit hidden.
Is it because the, let's see, it's because the prompt is too wide. It should say data flow in the end.
Yeah, I think it's very small.
Very small. I can increase the font size. It's better.
Slightly, yeah.
Right. Let's run the flow here. Now we can publish messages on the stream here, so we can say hello. And now I can see messages here. So text is hello user, this is my user ID. Then we have the channel here. And for the participants, feel free to post stuff into the Slack stream here. It's fine. We will get some data into our streams without me having to post stuff. So yeah, like people are now doing. Yes, thank you. So one more thing for the step 1 is that we will add a simple filter operation. This is to basically remove from the stream certain items. So we are going to be doing it based on what channel the message is posted. So for that one, we are going to be using this filter operator. We are giving it a name, filter channel. We're saying that please take the upstream from this variable stream. And then for each of the items in the stream, we call this function called channel is, which I am inputting here. So what this is doing effectively is just creating a closure for this channel ID, and it returns a function which just effectively returns a Boolean for each of the Slack messages, whether it is in the given channel or not. So I will also import the Slack message here. And now the Slack channel ID is actually read from the environment, which means that it is written in the .env. Here I have set it to this value, C06JE, etc. I can show you how to get the channel ID from here. So for the general, you click on the arrow icon, then you can scroll all the way down, and this is where you can find the channel ID. You can just copy it from there and paste it onto the .env file.
Let's share the file as it is as well.
What?
Let's share the .env file.
Yes, we can actually. Yeah, I can actually put the whole file in there. Let's see. Go back here. This is the contents. Now it's also that message is getting to my stream here, so I'm getting it back. Yes. And where was I? Yes. And if you want, you can create more channels in the workshop or in the workspace here. If you create a private channel, you need to manually add the bot there, and remember that even if it's a private channel, the bot will still get all the messages, and those messages will be sent to all streams. So you cannot just create a private channel and have a really private conversation with the bot. Everyone will get those messages, even though they cannot see it on the Slack client. Yes. So now I have the filter in place. So let's rerun the data flow. Connection is open. So now it is connected to this general. So I can have this this is a message. Okay. Message is coming through. But if I post onto random, I can say here that hey, this is a message to random. So now we should see that it gets to this debug, because this debug step is before the filter, but it did not go to the std out stream. So the first one on the general channel go through, but the one in the random channel doesn't go through. So this is how you can filter out your content. So if people are posting and spamming on the general channel and you want to try out something separate, you can just create a channel and then post your own messages there. All right. Now we have completed the step number 1. Then for the step number 2.
Should we pause for any questions?
Yes, have you, Mikko, been checking the
questions?
I've been
questions.
monitoring the chat feed. I think we're all good. I think everyone's questions have been answered.
Yeah, Mikko is posting replies there. Yes, so right now I am writing the code into this dataflow.py, and I'm running it from the dataflow.py. But we also have in the Git repository already all of those steps. So we have step 1 through 6 here. So if you just want to run the code from the current phase of the workshop that we are in, you can just run that file directly and it should already work. But if you want to go hands-on dirty, then you can just write it as we go. Okay, anything else? Step 2. So in here, we are now doing a branch operation. So our Slack bot is going to be based on 2 things. So there's going to be the conversation summary, and then there's going to be questions about the summary and about the documents. So to be able to figure out if a message is a question or it's just random conversation, we're going to be doing a branch operation. And for that one, we are going to be using let's see, I will open the step number 2. So for that one, we are going to be using the branch operation. I will actually, let's see, I will copy, see if I can do this live here, or will I have to resort to the actual predefined inputs? Okay. We are now doing the first operation here. We are using this key on operator, and now we are creating a key on the channel of the message. And this is not strictly required here, but one of the future steps in the pipeline will require the stream to be keyed. So we are adding the key on the channel here. And now, if you want to extend, you can basically do this such that you are actually maintaining the state based on the key. So you could have this single bot handle multiple channels at the same time. So it would be keeping on the summary, on the general channel, and then the random channel. And then once a question is posted on those channels, it could actually fetch the content from that specific channel and then give the results based on that. But for now, we are just putting the keyed stream there so that our windowing will work. So for that one, we need a function to actually get the message channel. It's again a simple function here. Let's see what else do we have here. Then we have the filter, and that needs to take in the feed stream. Yeah, I'm using MyPy for error handling here, and it is really good with the Bytewax because all the operators are typed, so it's actually able to give me good error messages when things are not going the way I want. So now it should be good. Let's see what is it complaining about. Incompatible type. Let's see. It will crash when it runs if it wants to. All right, but then we get to the actual branch operation. So here we are using this function called isMention to branch the stream based on the message content. And if we check what the isMention function is doing, is that it will now get a tuple of a string and a Slack message. And this is the result from us using the keyed stream. So this string here is the key for the item, and then the second one in the tuple is the actual payload. So in this case, a Slack message. And in here, we are just interested in the message. So we are assigning the message into this variable here. And now we are just checking that, hey, does the message contain the identifier of our bot? So now we can see if it runs. It's still showing me something red. Yes. Oh, I have some steps with the same name. Let's see. I will just do a quick this. Yes. So now the stream is running. So I can say here that, okay, this is a message. We can see it here, message channel, this channel. Okay. What is going wrong? Tuple attribute. So this is actually a tuple. Yep. Or it's not. Let me do this instead. Here.
Doing message.channel. Someone noticed in the chat.
What
message is a tuple?
What said? Who said in the chat what? Oh, it doesn't scroll. Message is a tuple. Yes, but now. Yes, now it's running there. So we have the message here. Now we can do a mention for the Bytewax. So we can say, okay, this is a mention. So this should now be coming here as a mention. Yes. So now when I copied stuff from the step 2, I got actually additional stuff. So the next thing that we are doing for the messages is that we are creating a windowed operation. So we are not actually processing those one at a time. We are gathering n messages together into a chunk, which we will then post to the LLM at a time. And the reason for that is that if you do it for every single Slack message, you would have very, very many requests to the LLM API per second, and it's just gonna slow down the whole stream. So what we end up doing is that we are actually creating a 10-second tumbling window. And for the Bytewax, the way you create that is that you have this event clock config, which is just basically saying that, okay, how do I get the timestamp from an item in the stream? So for that one, we are using this timestamp attribute of the Slack message. Then we are creating the tumbling window. We are given the time delta, so how long is the window? So we are saying here it's 10 seconds. You can customize this one. If you make it really short, then you're gonna end up getting a lot more frequent calls to the LLM API, but then again, you are also getting more throughput from your stream. We are aligning that 10 seconds to some random day here. It really doesn't matter with a 10-second window where you align it, but anyway, you need to give it. Then we use this operator window collect window function to actually create the window. We give it the upstream messages, so we are not giving the mentions, but we are giving the actual messages that don't contain the Bytewax mention. Then we are giving it the clock config and then the actual tumbling window. And then for that one, we are outputting the windowed messages into the STD outside. So now we can run the stream. So if we do message here, we should see, yes. So in here now we can see the window. So we actually got, how many is there? One, I think 2 managed to get into that 10-second window, and then the third one went into the next one. So this is basically just this is a way for you to process the messages in batches.
Pekka,
Yes.
question. There's a question in the chat. Is the 10-second window increasing the response latency?
Yes. So basically, well, it depends. It depends. In this use case, the way we are joining the streams that will come in the step 4 or 5. The way we are joining is that once a question comes in, it will get the most recent summary at that point. So if the window is still open and the question comes, it will get the previous window from there. It will not get the new summary from the step. But that also means that it will not increase the latency for the response. But what you can do is that you can also make it such that it will wait for the summary to go in. You could basically do an operation where you check the timestamp of the question, and then you would make sure that all the messages that have come before that timestamp would be included in the summary when you join the streams. But we are not doing that right now in here. All right. If nothing else, someone is asking that, are up late, what is our end goal here? So yes, we are building a supercharged Slack bot. So people are typing messages in this Slack channel here, and then we are having the bot running and getting the messages and doing stuff with them. But I think the next step, number 3, is when we get to the actual exciting stuff. So in here we are now taking the left side of the branch So those questions that did not contain the mention of the bot, we are taking those, and we are actually building a summary of that conversation using the LLM. So for the LLM, we are using this Yokotai, which is basically Softlandia's proxy for OpenAI. So you can use this one, and we have included the API key in the .env file, which I shared in the Slack at the beginning. But if you have your own, let's say you have an OpenAI API key for, let's say, GPT-4, you can configure that in the .env, and it should work, and that should give you even better replies than what the Yokotai here will be giving. We have given the free access to the Yokotai service, and it's currently using GPT 3.5. Let's get into it. Yes, let's see if for this step I managed to do it without creating too much bugs, and see if I can do it without having to copy paste the whole step this time. Yes, so we have the windowed messages here as the last step. So the first thing that we are doing is that we are creating a stateful step for the stream. So Bytewax is a good stream framework because it can do steps that actually manage state within them. So typically the way it is done is that you create a step with this stateful map, then you give it two parameters. The first parameter is a function to create the initial state. So basically for the summarizer, the initial state is going to be, there is no summary. But then you give another function, which is then going to be the function that takes in the previous state and the data from the upstream, and then it generates a new state with that input, and then that is passed on from the stream both into the next downstream element, and also it's going to be passed back in as a new previous state for the next round. So in here we are actually using a function object. I will copy that whole class here because it's way too long to type. But for this one, we are using a callable object because we want to actually embed our own attributes into it. So we have this LLM client, which we can create with this function here. So it's just basically an OpenAI Azure client. And for that, we need to import OpenAI. Yes, so we are creating the LLM client, and then we are creating a system prompt. So this is now when we are actually getting into the AI things. So this prompt here is just telling the step what to do. So it's saying that your task is to maintain a summary of the current ongoing discussion. You're given the current summary, which can be empty, and a set of new messages. So this set is now one window from the previous step in the stream. And then the contents of which you will add to the summary. Try to keep the summary under 200 words long. Then it's giving the model information. Okay, this is how the messages will look like, and then this is what the current summary is. So this is what it wants to. This is how to basically take in the previous state and use it as information to create the next state. So then we create the initial state. I need to add this is now. We're creating a new type for the summary just to help out the type checker to give us better error messages so that we don't need to spend time debugging, which we of course don't have to do. And then I will import the window metadata because that's needed also by that step. So yes, so this call is effectively now the way for this function object to define the way you call it with the, if you call it as a regular function. So this signature here looks like the regular function signature that you should be giving for the stateful map. So we have this previous state, and then we have the item that we are getting. So we have now the window metadata and a list of messages. We don't need the window metadata here, so we just throw that away. Then we format the system prompt, so this prompt that we have here, and we put the summary, so the previous state, in here as the current summary. And now for the initial state, we just have a summary that says no one has said anything yet. Then for all of the new messages that have arrived during that window, we put them into the prompt in the format of a list. So we have a dash, then we have the user ID, a colon, and then the actual text for the message. So it will be in the way that we have now specified that for the model. Then we call the LLM client chat completions create. We tell it which model we use. In here, it's GPT 3.5. Then we give the messages. So in this case, we have the system prompt, which is this one here, and then the user prompt, which is actually the messages that were posted on the stream. Then we get the content from that response, and we make that a summary. Then we return that as a new state. So we want that on the next iteration of the step, this value is actually going to be here in the current summary. And then also as the second element of the return value, we are giving that summary downstream. So this is getting passed on to the next steps in the Bytewax stream. So let's see if I now have everything in, or did I forget something? We will see. Stream is open. Oh, but what am I outputting? I'm outputting windowed messages. I should probably output something else. Yes, I should output summary stream.
There's some people joining and going as we speak, so now we are building step 3.
Yes. Yes, for some reason this Zoom chat does not auto scroll for me. So if I want to see the newest messages, I actually need to go in and focus on the window and scroll it down. So if Mikko, you can keep an eye on the chat, that would be perfect. Okay. Yes, so we are now outputting the summary stream to the std out sync. Right. Now this is getting let's see, do I have some let's have some discussion and go. So how is this workshop going? Okay, it got into the stream. Let's see, now it should be having the summary here. So discussion has the discussion has just started with username. This is my ID, is asking about the progress of the workshop. Now someone is saying hello team. Let's see. We should be getting a new summary. Let's see. So what? Amazing. Let's do sunglasses. Okay. There we go. Actually, yes. Discussions are going on. I think we can check if we do a working info, we should be getting a little bit less stuff coming in. No, it doesn't print anything. Okay, so we're getting the message here. So it's coming here, then it should be going. So we're doing an HTTP request to the LLM. Yes, and the summary is that the discussion has just begun with the user asking about the workshop. Then we're getting more. Okay, user, this one mentioned that the session is going to be with the blessings of the demo gods. Yes, that is very much true. And this user gave kudos for doing the session live. Yes. Yeah, we were actually a little bit frightened that once we saw the amount of RSVPs reaching almost 400, that how well is our Slack going to be able to handle this one. So now the incoming messages to the stream, those are handled by our own proxy, and we are pretty confident that that should be able to handle a couple of hundred users just fine. But once we get to the point where we will be sending stuff back into the stream or back into the Slack channel, then if there are 200 bots doing that at the same time, then there might be some rate limits that we will hit. But let's do that at the end of the workshop. So if we end up breaking the Slack bot, then let's do it at the end. Yes, so Mikko also stated in the chat that we are able to serve more requests faster. So I think there are there like 12 instances of the LLM that OP set up for this event. There was first only 4, but then we checked the amount of people who were joining this workshop, and we had to triple that one, but it should be enough. Yeah, so we are 50 minutes in, we are on time. We can go to the step 4. So for the step 4, we are now adding a vector database which is containing relevant information that the bot can use to further improve the answers that will be given to the users. So we are using this really nice vector database from Quadrant, and we are using fast embeddings to actually vectorize the data and the questions that we are getting from the chat. We are using an in-memory version of Quadrant in here, so we are not having a full instance of the vector database running, but we are actually storing those in the client side, which means that each time we start the stream, we need to also recalculate all those embeddings. If you want, you can have your own Quadrant Docker container running. It's rather simple to do, but we are not focusing on that in this session here. So with the RAG, this is now going to be the retrieval part. So we are getting the relevant documents from the dataset. And we have pre-configured the repository with a dataset.txt. It's in the data folder in the root of the document. We are just naively processing it by splitting it in double new lines to get chapters, and then store those chapters as separate data entries. You can You can customize that if you want. You can do like windowing, rolling window on the data so that you have some overlap, or you can go quite fancy with this one, but we are doing it's simple here. The content of that file is just some copy paste from the Bytewax documentation. So that's something that we can use here in the demo, but if you want, you can put your own data there. Feel free to have a bot which knows about cooking or knows about different code editors or whatever you like. So let's go for the step 4. So what we are now doing here is that we are doing a new step, which is mentions with context. And we are using the map operator here. So we are taking in data in one form, and then we are, for each of those items, we are generating a new item of data. So we are not creating new items onto the stream. We are mapping the old items into a different form. And for that one, we are going to be using this context retriever. And if I remember correctly, that's another closure. So we can put it here. So we are basically creating a closure that gets an instance of the document database and keeps that in memory for each of the calls to the mapping function. So the mapping function here, it's taking in again the key and then the Slack message. So this is the one that contains the question. Then we are unpacking the tuple, and then we are doing a search for the document storage, which we will be adding in just a bit. And then this result we are actually wrapping into another new type object, and this is again just to make the type checker a little bit more useful for us. I think that was just a list of strings here. Yes. And for that one, we are going to need a document database, which is something that we have also provided for you in this utils directory. So this is a simple client for the Quadrant document database. So what we will do is that we will initialize the Quadrant database before building the data flow. So we are creating the database. We are giving the embedding model. So here we are using this BAAY/PG small. So this is I think, like 500 megabyte or something model, which will be used for the embeddings. Mikko, do you want to share some extra details about the embeddings?
So the
Sorry, I was yeah. So yeah, the embeddings are the primary way how Retrieval Augmented Generation apps are mapping the user's question to the data that we want to use for answering the question. So it is a way to derive a numerical representation for your text data. And like Henkka said, we are now computing the embeddings here locally, because every time you start the stream, we will re-embed the documents that you are using in this demo. So you can freely start and stop and restart the stream, and you will always get the latest embeddings for your data. If you change the data in the data folder, just restart the stream and you will have access to the latest documents. But yeah, the Qtrand vector database provides a very tight integration with some selected embedding models, which we are taking advantage of here. but if you want to adapt the code, you could use any embedding model from any service and embed those instead. But yeah, here we are using the fast embed from Qtran to do the embedding. That's in a nutshell.
All right, yeah, there are already people asking that, can we ask a question and get a response through this demo? Yes, that is what we will be doing if we get to the step 6. Yes, just try to be patient. We are halfway through. Okay, so as Mikko explained the embedding model, so we are now creating the document database, and we are telling it that, hey, okay, use this model. Then we are uploading the dataset. So we go here, a little bit small. So we are having this upload text chapter-wise. This is really simple way of doing it. So we are reading the file, the whole text in the file. Then we are splitting it with double new lines. Then we are just creating a index identifier for each one of the chunks. We are maintaining the state of the index within this object itself. So if you call this method many times, it will create unique indexes for all of them. And then for the metadata, for now, we only have one document, but what you could put here, actually, I think we could put the file path. Let's do it like this. File path. And then let's do the name, so it only uses the name as the source here. But for us, in the example, we only have one document, so all of them will have the same source. But if you want, you can put 10 documents in that directory, and then you just upload all of them into the database, and that should work just the same. Then we call the client.add with the chunks and metadata and the identifiers, and then those will be uploaded to the document database. Yes, we can actually run it here now that we can see loading documents to the database. It will take a couple of seconds. My computer is really slow with this one because one is much faster. But for me, it has been taking something like 17 seconds. That's quite long for fast embed. Mikko has it going for 3 seconds, but this is an old janky Linux laptop, so try to bear with me. And I have 3 monitors connected to this one. It's really struggling with the Zoom chat and screen share and the webcam and everything. So let's hope that it can manage until the end. Yes, so we have created the document storage. Then we are actually creating the mentions here. We are calling this the retrieve, because it is now retrieving the information from the document storage. It's getting the mentions as the upstream. So this is from the brand step. So this is the right side of that diagram that we have in here. So then we can actually output those in here. So we can do mentions with context into the std_out stream. So now again, waiting for 17 seconds for the documents to load. Now when I think of it, it would have made sense for me to set up the Docker container for the quadrant so that I could not have to wait for this one every time I start the stream. So let's hope that I will not have to do debugging too many times. So now if I do a mention for the Bytewax, okay, how can I run Bytewax Bytewax in Docker. Let's ask it like this one. So now it will output the message here. So again, the key, then there is the message, which says that, hey, how can I run Bytewax in the container? And then we have a list of elements that we fetched from the vector database. So, okay, first one is source for Bytewax is hosted on GitHub Dataflow. Programming import Bytewax operations is up, blah, blah, blah. Okay, relevant to Bytewax. So basically now this is taking the question here, which is the how can I run the Bytewax in a Docker container. It is taking that text, it's generating the embeddings from that text, and then it's doing a nearest lookup or similarity lookup from the vector database that, okay, these chunks that we now generated, these are the ones that most closely are related to this question that I asked. And now I think I asked it to fetch me 10. Yes, it's going to fetch me at maximum of 10 entries from the file that I just uploaded. Let's see if I can ask it, okay, how do I install Bytewax? Let's see. Pretty much similar things. Let's see if I can look at the data set here, and let's see. Yes. How to contribute. Let's see if it can. Someone is asking. Better way to format this in the console would also have been a good idea. Anyway, yes, Mikko is giving good input in there. Let's see if we can. Let's do a copy paste of something in the. Should at least, yeah. So now it at least is giving me some context for the logic functions. Let's see, have I already started this one? Yes, I have already started. So I don't need to shame. All right. Okay. Doing the answers in here. Are there any questions ongoing? How do we get the recording? I think it's AI Camp can respond to that one.
I think they're going to post it after the session. I don't know how long, but at some point they will.
Yes, and also the source code for everything that we are doing here is going to be available in the repository. Since we are using the proxy here and we are not connecting the Slack directly, it means that once the workshop is over and the proxy will be shut down, the code itself will not run. But we will share the source code of the proxy also in the same repository, so you can set it up by yourself, and you can then install the bot onto your own Slack instance, and you should be able to get going from that. What you can also do is that you can, once you are implementing this for your own Slack and you don't have 300 participants using the same instance, then you can actually drop out the proxy and use the Slack API directly from the stream. That's the best and most efficient way of doing it, but it unfortunately doesn't scale like this. Okay, any other questions? You are editing data.flow.py, but will it be in step 6.py? Yes, so what I'm doing here is that I have the steps there, step 1, 2, 3, 4, 5, and 6 as a runnable scripts that I know that will work. And then I'm coding the same thing. I'm basically building step 6 live here into this data.flow.py, and I'm trying to at least make some of the mistakes that you will be making so that we can debug things together. Yes. Anything else at this point, or should we go to step 5?
Let's maybe take a recap what the bot does now and what we will add in the next step.
Okay, so let's walk through the data flow once again. So first thing we do is that we load the document database with the pre-generated data that we have for this Slack bot. So for us, we have just a small copy paste from the Bytewax instruction manual. Then we create the data flow. We define the input to be a Slack source, and we give it the URL to Softlandia's Slack proxy. Then we add a key for each of the items that are coming or from that stream, and we are just keying them based on the channel that the message appears in. And this is not used in here, other than it being mandatory a step for using the window later in the stream. But you could build this stream such that it can handle multiple channels based on this key in parallel. Then we are doing a filter. We are taking messages from that keyed stream, and we are filtering them based on the channel ID of the message. So we take from the .n, okay, this is the Slack channel that we want to listen, and this tells the stream to throw away all the messages that do not match that channel. Then we branch the stream into 2 parts. So we get the messages that have not mentioned the bot in the message, and we get the messages that have mentioned the bot. And mention looks like this. It's just this mention. It checks whether that is contained in the message. Then we have just some inspect steps to ease out the debugging. Then for all of those messages that did not contain the mention, we are basically windowing those such that we take 10 seconds and we collect all the messages that arrived during those 10 seconds into a window, and then we pass them on in the stream as a list of 10 messages. So we are not processing them one at a time, but we are processing them in chunks. Then for those chunks, we are giving them to a summarizer, which is a stateful map operator in the Bytewax stream. So it basically takes in the previous state, which is what was the summary of the conversation before that chunk of messages arrived. And then it gets that chunk of messages. And then the task of that state is to create a new summary of the discussion based on the previous summary and the new messages. And then that is passed on as a new state for the stateful map. And for that one, we are using the LLM to actually summarize the conversation for us. And then what we're doing is that we are augmenting the questions or the messages with the mention. We are getting the most relevant documents from the document database based on the text in the message, and we are then just passing those along with the message into the downstream, and we are outputting them into std out state. Okay. Now, hopefully everyone is still on board, and if not, feel free to take in the step5.py and just start running or editing that as we go. Or you can type and code with me. That's also fine. So the next thing in the step 5. Yes.
Let's address the last question in the chat at this point also.
Yes, for the actual, let's see, where did my string go? Yeah, so for the Slack message, what I have done here is that I have defined the stir method for the Slack message. So instead of showing that weird tuple kind of like thing, it shows the channel ID and on, and then user says something. And the way the std outstream works is that for each of the element, it will call the stir method to print it onto the console. But the problem, once you are using something that is a little bit more than just a single object, it's tuple or something else, is that it will no longer adhere to the stir methods of those individual objects, but it will instead just do a stir of the whole tuple, which unfortunately takes in each of the elements and calls repr for it. But what you can do, I'm not doing it here, is that instead of returning a tuple, you can have a mapping step which actually takes in the tuple and extracts something out of it or combines it into a new object. So what we could actually do here, so if we have the mentions with context, let's do some, let's see, what was this one returning? It was returning a tuple of, so we can do define mentions with context, and for this one we can use a lambda x, and now I need to check what is the so it's just a tuple of, let's see if we can get it like this. Here. So we get the x, and then we get the this should print now just the, let's see, it's complaining still something. Variable is assigned, never used. Incompatible type. Compatible return value. Let's see if it works. Yes, so now it actually got the Slack message object from there, and now it's using the stir method of that Slack message object as a item to print onto the console. We could probably also do something for the checking on the clock. Yeah, we have.
Yeah, go step 5 soon.
Yeah, we have some time. So if I get this second element, which is actually the context, which is a list of strings, so I should be able to just do this. So now there should be strings. So let's see. We run this one. Oh, and painfully waiting for the 15 seconds for the documents to load. Okay. Let's see how bad results do I get from the database this time. Yes, so now it's actually printing out those context messages properly. So this is how you can make it easier to read the console output of the stream. A little bit clumsy, but should work. Any other questions at this point?
Let's go.
Yeah, let's go. So I'll take this pretty wise step out, and we are continuing. So step 5. Did I explain the step 5 here? Mikko, Not yet. Okay, I completely lost my thoughts. Yes, so now what we have done previously is that we split the stream into 2 substreams, one for the actual discussion items and then one for the mentions. And now we are bringing those routes back together. So we are using the join operation. And the way the join works in Bytewax is that you can either have a non-running join or you can have a running join. And the way that non-running join works is that once you get a new element in both of the upstreams, it is going to emit a new element downstream. But then a running join is such that if either of the upstreams changes, it will emit a new element downstream. So you end up getting duplicate elements for one of the streams. And in our use case, we are mostly interested about the questions. So ideally, we would use some sort of way to say that, okay, this upstream is the master stream, only emit new elements if the stream on the right changes. But at least I didn't find a way to do it in Bytewax, so it was implemented in another way. So we have this running join, which just emits a new element if either one of the upstreams changes. And then we have another stateful map, which just keeps track of the element on the right side, and it emits a new element only if that right side changes. So let's hop back into the code. So we have the join. So we are using the join operator from the Bytewax. We call it join streams. We are giving it as an upstream, as a left side upstream, we are giving it the mentions, and as a right side upstream, we are giving it the summary. These are actually flipped from the image here, but just imagine them mirrored. Then we are setting the running flag to be true so that we actually get the behavior that I just described. Then, since now, if I would leave it like that, we would get extra elements into the stream. So basically, if you have a discussion ongoing and you get a question coming in, okay, that question will get the current version of the summary, and it will get passed, and it will get replied. But then if there is new message coming in into the conversation that is not a mention, that will generate a new version of the summary. And then it will basically emit the same question again to the downstream and respond to that same question without anyone asking that. So what we will need to do here is that we are adding the filtering step. So that is done with 2 separate steps. So basically, at least I did not find a way to do it in one step. So what we need to do is that we have a step which effectively keeps track of the previous question ID, and then it sets a flag if the question is something that has not been passed to the downstream before. So we have this join summary to question. Let's find that function in here. Let's add it to here. So what this one is doing is that it gets the previous state, which is a identifier of the message. It can be none if there has not been any question in the stream before. So the way that the running join works is that if one of the streams or one of the upstreams will be the first one to change, and at that point the other stream does not have any content yet, so that will be just passed a none. Then we get an item, which is an augmented message, and then we get a summary. So I need to define the augmented message. And this is effectively just a prettified Slack message. It's another data class which I need to import. So this is just a way for me to print this message in a nicer format. So we have the summary, which is the discussion summary. Then we have the context, which is the data from the vector DB. We define a stir method to actually print it out nicely. So now we can go back to here to the join summary to the question. So we get an item, which is actually a tuple. So we have the augmented message and the summary, and we have the, oh, wait a second, do I actually have the, I think I also, context retriever. Yes, so in here, one extra step that I do is that I modify the context retriever so that it actually returns me an instance of the augmented message instead of the tuple. So I will replace that function here. So this is just to make it easier to print this one. You can use it as a tuple of a tuple of a tuple of a bunch of things. It also works, but it's a little bit harder to keep track. So, okay, so now we get back to this one. So now we get an a item here. So the left side is from the one stream and the right side is from the other stream. So if we don't have any messages yet, so this means that we did not have a question, we just had a new summary posted. So we return none as the new state. So none is going to still be the ID of the previous question that was asked, and then we just give none as the downstream item and false as the flag for this one. So we don't want to keep this element in the stream. If we don't have a summary, but we got a message, that means that someone asked a message from the bot, but there has not been any discussion on the channel yet, so there has been no summary. So in that case, we just use the initial state of the summary object, which effectively is no one has said anything yet. Then we augment the message with the summary. So we just attach the list or the string into the message object so that we can have it passed on as a one object instead of a tuple. Then we return the message ID as a new state for this one. So for the next round, we know that, okay, this message ID we already have replied to. Then we give out a tuple of message, and then we give as the flag that, okay, was this message same as the message that we replied to in the last iteration of this step. So we don't filter anything out yet in here. We are just setting a flag which is going to be false for those messages that we want to filter out. Okay, the recording was stopped and re-recorded. That's fine. Then the next thing that we do is that we implement a filter step. So we put the filtering over here. So we take in the flagged stream, and then for each element in that stream, we only keep the ones that this has unique flag set returns true for. And this function is just taking this unique flag, so it's ignoring the key and it's ignoring the actual message or the question. It's just checking the flag and then returning that as a boolean from this function. Okay. Then I have another step, which is just let's remove the flag and the keep. So in this case, I'm just mapping the messages into another format where there's only the message or the augmented message and not the key or the flag. And this is again to make it easier to print it out to the console and also make it easier to define those functions, because I only need to take in a single object and not a tuple of a bunch of tuples. So that we have the questions, and then I just update this to be questions here. Let's see, will I get a demo effect? And while it's loading the documents, okay, there we go. Now I should have the stream running. So let's ask a question. Tell me something nice. Summarize a create initial state. It's giving me an error which says type error. Supercharge, okay. Missing one required position. Oh, yes. So I think I made this one a class method here. And again, waiting for the 15 seconds for the documents to load.
Do we need to invite the bots?
For the public channels, I think we don't.
Already answers.
Well, click the invite. Okay. I don't. It might also be that it's not able to send messages to this channel.
I will invite.
I already clicked invite. Let's. For the if you create a private channel in there, you actually need to invite the bot for it to actually be able to see the messages. But for publishing the messages, it might be that for the public channels, you need to do it. Now, if someone is running the step 6 already, we'll start seeing stuff coming from there potentially. Okay, document loading finished. Let's run Bytewax. Okay, so now we get a nice thing here. So we have the summary. No one has said anything yet. We have context, so many words here. Okay, that's probably something nice. Query icon URL service, that's definitely something nice. What else? Bunch of parameter inputs. Bytewax also offers a platform that simplifies the management of stateful workloads on Kubernetes. Everything that contains Kubernetes is nice. I think that's where the vector search found that one. Okay, let's go. Let's add some discussion in here. I think Kubernetes is very nice. Okay, we got a message. Go. It's gonna be building the summary. Let's give it something. And we should be having the related summary here. So, okay. This has been mentioned as a topic of discussion by who holds a positive opinion about it. How a GPT way of saying this. No further discussion has taken place yet. Okay. Call me cube control. Let's get. I want to see how GPT summarizes that one. Users jokingly refer to themselves as cube control. Oh, perfect. Okay, 25 minutes to go. Let's continue. We have finished the step 5. So
at this point, we're getting answers in the terminals, but it's not yet posted to the Slack channel.
Yeah, so now will be the time that we break the Slack workspace or the proxy. So we are now going to be generating a response to the question with the Yokotai, and we're going to be publishing the response back onto the Slack channel. So let's get in business. Don't need that right now. Step 6.
Did you show the summary slide?
What?
Did you show the summary slide?
I think I did.
Okay,
it's
good. I wasn't watching.
The step 6 is really short in the summary slide, but very exciting in the Slack side.
Okay.
Yes. So what do we have here? So we will add 2 things. Okay. Having a yes, so we will have a response, a generate step here, which is getting questions as a upstream, and then it's given a generator as a function to call. This is again a function object, which is going to be using the LLM to generate the responses. Let's put the generator here. So we're using the same method to create the LLM client, and then we are giving a prompt that, okay, your task is to assist the people in the discussion by responding to their messages. And we're telling that, okay, we are giving you additional context of what the discussion has been about. And then the users will be referring to you as a ID of the bot. So this is just to make the LLM not be confused about what is this string here. It just tells it that, okay, it's referring to the bot. Then we are providing the summary of the discussion. So this is coming from the left side of the stream. And then we have a section for the documents. In here, I put some indicators for the beginning and the end of the section, because there can be pretty much anything in here. But this is then something for prompt engineering, that, okay, let's see how the model will behave. For some models, you will need to do something, and for other models, you need to do something else. Feel free to customize anything in here. Then I'm telling the bot, okay, you can use the emojis with this emoji syntax. And this seems to work much better with the GPT-4 than it works with the GPT 3.5. Maybe it's possible to get it working better with the 3.5 also by doing a little bit of prompt engineering. Feel free to modify and try things out. Then giving instruction to it that, okay, your response will be shown in the chat, so just respond as if you were one of the participants. And then we tell it that, okay, this is how you can mention users. This is how the syntax works. Then following message will be the question. So the next entry in the messages list will be actual question from the user. So this looks quite similar to the what we got in the previous stateful step, or the previous LLM step. We create a system prompt, we format it with the summary and with the data that we got from the documents. Then we take the text that we received from the user message as the user prompt, and then we create a completion from that one, so we get the response from the LLM. And then we are just putting that into, instead of returning it as a string, we are putting it into a Slack message, telling the username is Bytewax, and we're giving it the message ID. And the way this works is now specific to Slack. So if you want to respond to a message, you actually have to refer to the message's ID, which actually is the message's timestamp. So you tell that, okay, that I want to put my response as a reply to this message. You actually can see already that Mikko is trying out things there. Oh, there are 2 replies, so I think there's more than one person already having this stream running. So then we put the ID of the message here, so then the Slack knows basically to which message this message was a response to. Then we give it the channel, tells where it goes, so it should be the same channel where the original message came from. We put the LLM response in the text field, and then we give it a timestamp. Okay. For now, we can still keep it in the Slack sync. Yeah, and this is the time when we start having those questions in the chat, which are no longer questions to me, but questions to someone else. So that makes my life a little bit easier. Okay, so I don't even need to type anything there because people are mentioning the bot constantly. So we can now see here that, okay, these are the, oh, wait. Yes, and I'm of course printing out the wrong stream. print responses. Yeah, this is how you get bugs. Painstakingly long, 17 seconds to wait. Document loading finished, so let's see if I can. Let me ask, should I go scaling exactly there? Depends on your location and the weather forecast. Looking out from the window here in Finland, I would say both the location and the weather forecast should work out for the skiing. You might have mistaken me for a weather forecaster. Yeah, now I no longer know whose what is doing what. One quick tip here is for people to put in is that instead of returning the response directly, do something like this: my name or my nickname. If you do this one, then you will actually be able to identify that which one of these replies is coming from which bot. Okay, so now my stream is not actually running or replying to the Slack, but it is putting it onto the std out, but now I should be able to just replace this with Slack sync, which I need to import. Slack sync, and that should get a URL, which is, what was it called? Proxy. Yes. What's Nazgul's favorite open source library? Oh, these are amazing. Pyo3. Yes.
I mean, Pyo3 is a great library.
Yeah, for people who love both Python and Rust, can't have anything better.
Bytewax wouldn't be possible without Pyo3.
Yes. Okay, let's see now. Also, my bot should be replying. I would like to get some snacks after the workshop. Any places to recommend? Yeah, by the way, now we effectively have finished step 6. So this is now the time for the demo, and quite frankly, the demo is ongoing live here in the Slack.
There was one last question about the 2 answers.
Let's see.
Maybe it's
Why are
just
they always
formatting
2
thing.
answers? So basically, it depends on how many streams you have running. So now when you have the message and the mention, that will actually go through each and every one of you who is having the stream running, and then each and every one of you who has finished step 6 is going to have the reply be posted as a response to this message. So if we have 30 people who have the step 6 running, we should have 30 responses to each and every one of these questions here. Let's see, now we have 3 here. Things are rolling in. This is now also a live feedback loop for us to see how many people have actually been able to complete the workshop.
Yeah. How many bots are alive?
Yes.
Heikka, if somebody wants to personalize the bot, where is the prompt that is instructing the bot to answer?
Yes, so the prompt is here in this generator class. So this is the text that you will need to customize to make the bot behave in a certain way. So you can tell that, okay, use this kind of wording, or you can do all kinds of things that you can do with the ChatGPT, for example. You can instruct it to behave in a certain way.
Oh yeah, there's a couple of bots online.
What?
A few bots online.
It's nicely using emojis in the end. Yes. Yes, Paul, especially the GPT-4 really gets a hang of the emojis. Let me see if I can have the yeah, sometimes also the GPT 3.5 is able to do the mentioning, like putting the @ sign in front of the person. Sometimes not. GPT-4 is again much more capable in that sense. And also what you can do there is, now since it's getting also the conversation summary, you can have some random messages ongoing in the chat. So that's actually what we did in the demo that is shown in the GitHub repository. Let's see if I can actually show that right now. So it's this one here. Okay. So this one. So in here we actually put some questions in the Slack that, okay, I need help of the usage of the filter operator. And then my friend is sending a message that, oh, I don't know, but maybe the bot knows. And then I will just post a question that, hey, Bytewax, help us. I don't give it directly the question. I just give it a hint that, hey, I need help with something, but then please fetch it from the current context of the conversation that what I need help with. And then it's able to generate me a response of how to use the filter operator. Of course, that response is not perfect because our vector database is not perfect, etc., but it's still able to grasp that I am not referring to anything directly in this question, but I'm referring to the actual conversation that we are having.
It seems really fast.
This here is a GIF which is edited, so.
No, I mean in the chat right now, when someone asks, its replies are really fast. Is some of it just like a cached summary? Like, so Ruben asked, can you summarize the previous conversations? And it was like within or under a second, it seemed like there were all the replies.
Like it doesn't take too long because because if the user has the stream running, it's going to be maintaining the summary constantly in there. And if they don't stop the stream, it doesn't take any time to regenerate the summary. But then once you get a new message in the question stream, that's going to just take in the current summary, fetch the relevant documents from the document database, and then do one call to the LLM API to get the response. So it's going to take less than a second.
Yeah. It's the different the different bots that are running are contradicting themselves. We need a third one. We need a third bot that, or sorry, not a third bot. At this point, we need a seventh bot that just removes all the contradictions. I think we'll probably have to run one of these for the Bytewax community Slack. Let's see how off the rails we can get it together.
You probably very much so. Oh, you don't know what I'm talking about. Yes, actually, something related to this pattern that we have here, that you have some discussion ongoing, and then I don't know what was the actual initial message there, but the one thing that we are not doing in the current stream, but what we could do is, as a note here, that we could do an additional lookup for the document database. So right now we don't do a lookup with the summary. So if you ask in the stream that, hey, I would need help with this and this and this, which relates to something that you have in the document database, that doesn't actually get included in the relevant documents that are fetched. So what you could do in here is that you would do an additional retrieval step that, okay, fetch related documents to the summary. And then you just append those to the related documents of the question, and then you generate the response based on that. That would give possibly more accurate responses. From
the WebSocket, do you get emoji like responses? Like you would, if you had like a designated emoji that said this was the right answer that the bot actually gave, would you be able to prioritize that in some way, or add that to quadrant?
Oh, you mean that you could have a reaction in here, or
or keep that information for future?
I think you could do that. Like from the Slack API, you get basically almost every single action that the user can do via Slack. You can get an event from the API for the bot, so you could build quite fancy things with it.
Yeah,
we are pretty much just scratching the surface here.
Make a like a store this thing, and then it stores the thread of the conversation to be retrieved later.
Yeah, we were actually thinking of having something like this in our own Slack, but we would probably be implementing it in some way that once we actually get the question, we would fetch a certain number of previous messages and then pass those previous messages as a context directly to the LLM. And we could use that in the, for example, in the management channel, that, okay, how is this tax thing going, and where do we need to put these reports and those reports, and then just would add Yokotai help us, and it would tell, okay, do this and this, and send the email to this person and include this information. If Ilmo is still on the line, he's probably quite excited.
There was a legitimate question on how to reach both of you if they have questions about the repo, the code. I'm guessing maybe repo discussion or issues or Slack or what.
Yes, so I am at least a contributor on that repository, so you can find my GitHub account from there. You can shoot me an email. You can create an issue in the repository That should be one way to address it. Also, our contact information should be available somewhere in the material, something like LinkedIn account.
I tried to teach it to react with the emojis, but it doesn't immediately obey.
I've seen a lot of people dropping off in the chat and saying thank you, and it seems like a lot of good feedback. Great work, y'all.
Thank you. Thank you.
Yes, I
Yeah,
think we are almost done with our workshop and the planned agenda. Yeah.
Yeah.
Any questions? I think there were a lot of interesting questions from audience. So, and I'm sure a lot of the participants would try from the GitHub on the use case that we have demoed today. I'm sure we had a lot of great insights with regards to retrieval augmented generation and how we can make use of Bytewax streams.
Yes. So we might. I need to check with OP, but I think it should be possible for us to keep the proxy running, for example, for over the weekend. So then the code would be working at least for that time. And the Slack workshop, well, we have a 30-day free trial, so we don't need to kill it immediately. So that will also be there. If we close this Slack workspace, then you would actually need to configure the Slack application into your own Slack, which is something that we are not covering here in this workshop. There's good documentation from Slack side. It's not that much work, but you still need to somewhat know what you're doing. But we can leave this one running at least for a few days for people to try out things.
That would be really amazing and helpful. Are there any more questions from the audience? I think we are good. I should really say that it was an amazing workshop, Henrik, Mikko, and Xander. And a lot of participants had shared their feedback on the chat as well, that it was really insightful and informative. Yes.
Thank you, and thank you for people for joining. Like, it's amazing to see this many participants here.
Yeah.
Yes.
Tell me about the creation of the world.
So
Cool. This was fun.